Alright guys, so in this section 12.4 we are talking about measures of dispersions, and there is quite a bit of definitions. On problem number 1 it was the measures of dispersion are used to indicate the spread or the variability of the data. What does that mean, the variability of the data? That means the data can varies and we must be very careful, and so the measure of dispersion help us to measure to indicate the spread or the variability of a data. Problem number 3, the measure of dispersions that measures how much the data differ from the mean is called the standard deviations. And we have seen already in a previous chapter the definition of the mean. And the mean is basically the sum of all the data divided by the number of data. Problem number 6, the standard deviation of a set of data in which all the data values are the same is 0, because when you are applying the definition of the standard deviation, you are basically doing the square root of the sum of each data minus the mean squared divided by the number of data minus 1. And if there is and if all the data value are the same, the data and the mean will be the same, and the difference between the two will be equal to 0, and so therefore the square root will be equal to 0 as well. So in this problem number 10, let's go back to the definition of the range being the highest value minus the lowest value, and the standard deviation being the sum of x minus the mean, x being the data, divided by n minus 1. So you must remember this definition very well. So when we're having to calculate the range, the highest value will be 16 and the lowest will be 8, so the range will be 8. 16 minus 8, the mean being 66 over 6, which is equal to 11. Why 66? Because you add 10 plus 10 plus 14 plus 16 plus 8 plus 8. Once you've done that, what I would suggest is for you to do a chart. And on this chart, you will put the data, then add the data minus the mean, and then the data minus the mean square. You will calculate the sum of the data minus the mean squared, and then you just apply the definition of your standard deviation. And in that case, the standard deviation were approximately 3.89. Now you can see on number 12 that obviously the range will be equal to 0, and the mean and the standard deviation will be also equal to 0, because the mean is equal to 9. So I just calculated the mean, which is 63 divided by 7 equal 9. And so now you understand why 9 minus 9 equals 0, and why the standard deviation is also equal to 0. Number 18. So number 18, we have a range, and we are going to take the highest value, the highest data. It's going to be 850 minus 100, the lowest, and we have a range of $750. As you can see that I'm trying to organize my chart in order for me to have the data just right there. And then I will have x minus the mean and x minus the mean square. When I do the sum, I end up to find 428,800. And then when I calculate the standard deviation, I take the sum of x minus the mean squared divided by n minus 1, and I'm arriving to a value around 267.33. Number 23. So in number 23, we have a boy's physical development from 1 to 18 years. We have two different kind of a graph on the same pictures. We have a graph corresponding to the weight, and we have a graph corresponding to the height. Going from 1 to 18 years old. On this question number 1, it was what happened to the standard deviation for the weight of the boys as the age boys increases. What is the significance of this fact? Well, first of all, you can see that the standard deviation increase, and that is a fact. The second of all, there is a greater spread. If you look at the spread, there is a greater spread from the mean as they get older. So that is very important to notice. On the problem number 2, we're just focusing on the age 13, and we need to determine the mean, weight, and the normal range for boys at age 13. So when you look at your graph, you put yourself at 13 years old, you're going vertically, and you will see that the mean vertically is around 100 pounds, and the range is in between 60 to 140 pounds. If you look at the same in terms of height, you will see that the mean will be 62 inches and the range will be between 53 to 68 inches. At 17 years old, the mean in pound is around 140 pounds. And if I look at the weight, it's going to be 40, the standard deviation for the weight, it's going to be 40 pounds. Finally, the last question, assuming that this chart was constructed so that approximately 95% of all boys are always in normal range, determine what percentage of boys are not in the normal range. Well, you will probably understand that if 95% of all boys are in normal range, that means 5% are not. All right, I think I'm trying to correct very quickly all this problem because they're not that complicated in terms of calculation, but you need to pay attention what you're doing because otherwise you will be very quickly making mistakes. So now I'm going to do the last one, 12.5, and we will be done with this section.